Hi, welcome to Introduction of Hadoop. In this video, we will be covering what is big data, and then we'll be looking at what is the definition of Hadoop. After that, we'll be looking what is Hadoop distributed file system and what is MapReduce. After which, we'll be looking at how a cluster look like and what are racks in a cluster. So, after end of this video, the takeaway from this video would be you will be having a basic understanding of what big data and Hadoop is, and you should be able to explain what HDFS and MapReduce and how they work on, and how a cluster and a rack look like you should be aware of. Okay, let's quickly jump into what is big data. Big data is collection of larger data sets which are in petabytes, exabytes or zettabytes, which are difficult to be stored or analyzed in RDBMS. I'm repeating the definition. Big data is collection of larger data sets in the form of petabytes, zettabytes or hexabytes, which are difficult to be stored or analyzed in RDBMS. So, when I say it's difficult to be stored or analyzed in a relational database management system, there should be some specific reasons why we cannot store or analyze. Let's look at why we cannot store big data in RDBMS. Yeah. Before looking into that, let's look at how much of data that is being produced by various organizations. Let's say Facebook. Facebook is providing almost like 15 terabytes of data per day, and New York Stock Exchange is producing 9 terabytes of data. Okay, and British Telecom is producing 8 terabytes of data. Bank of America credit card related information itself would be 6 terabytes of data. So when these organizations are producing such huge data, there should be some mechanism to store the data other than RDBMS. Because when I say RDBMS, even though we can store this particular huge data, but how about the increasing trend of data? Maybe Facebook is producing 15 terabytes of data. Tomorrow it might produce almost like 30 terabytes of data. Where will we store it? RDBMS cannot store such huge data, right? So that's one reason why we cannot store big data in RDBMS. And second important thing is, why can't we analyze our big data using RDBMS? Consider a situation where your table is having employees of 1 billion, out of which you wanted to query all the employees having first name starting with A. So in this situation, if you had to join your employee table with some other table to get your employee ID, okay, so in order to query only the names having A as a starting letter, you'll take some time to filter out from 1 billion records. But the current trend is everything should happen in lightning fast. But RTBMS cannot offer you that performance. Definitely it will take some time to produce your data. So if that is the case, what is the alternative? If you cannot store your data or analyze your data using an RDBMS, what is the alternative for that? I would say there are many other tools like MongoDB, Cassandra, Vertica, but the best among them would be Hadoop. So why Hadoop is the best alternative? Because it has some inbuilt features. So let's look at what is the definition of Hadoop. Hadoop is a framework written in Java to analyze larger data sets using a distributed file system called Hadoop Distributed File System, which we call it as HDFS, and a programming model called MapReduce for parallel processing of your data. And this MapReduce we will call it as MR. I'm repeating, Hadoop is a framework written in Java that allows distributed processing of larger data sets using a distributed file system called Hadoop Distributed File System and a programming model called MapReduce for parallel processing of your data. So you have come across two technical jargons here. One is HDFS and other is MapReduce. So before looking in deep about Hadoop definition, let's basically understand what is HDFS and what is MR. For that, I have an example to explain you on high level what is HDFS and MapReduce is. So let's look at this example. Let's imagine a situation where my client wants me to put some 100 bricks from one place to another place. Okay, so when I have to put some 100 bricks to one place to another place, I have recruited a person. So that person's performance would be he can put one brick in 1 minute, but my client wants that job to be done in 10 minutes. But the person who I have recruited can only complete that in 100 minutes. So this is the situation. What should I do? I'll simply recruit 9 more people, totally 10 people, and I'll ask them to list 10 bricks and put them into the other place. So if each person is taking 1 minute to take a brick and place it in another place, so obviously 10 people would complete the task in 10 minutes, right? So what I have done is, when I have some 100 bricks to be placed from one place to another place, I have 10 people. I have split the work among 10 people and I made them to work parallelly so that my work will be done in 10 minutes. So that I will meet the criteria what my client had given. As simple as that. So in order to do that, the first thing I had followed is I had distributed the work among the people. And the second thing is I have made them to work parallelly. So from these two sentences, we can understand what is HDFS and what is MapReduce. Coming to the full form of HDFS, HDFS is Hadoop Distributed File System. So this is a file system which allows you to distribute your work so that all these resources can perform their work parallelly, which in turn increases your performance. So that's the beauty of HDFS, and that's the basic understanding of what HDFS is. And coming to MapReduce, let's look at this example. When I have 100 bricks to be split among 10 people, there should be one person who will split 10 bricks to each of this person. Person 1 has to work on 10 bricks. Person 9 has to work on 10 bricks. So there should be some mechanism to split this 10 bricks among 10 people. And at the end, there should be some mechanism to combine the result and to give it to the client. So when I have to split my work and when I have to combine my result, there should be some proper mechanism to do that. So for that, I am looking at MapReduce. MapReduce is a programming model which has two paradigms. One is mapper and second thing is reducer. Mapper splits your work, reducer combines your result at the end. So in this example, I'll use mapper to split my 10 bricks, and at the end to give the result, combined result to the client, I'll use my reducer to combine my result. As simple as that. So going to the definition of Hadoop back. Okay, let's look at the definition once again. Hadoop software library is a framework that allows distributed processing of large data sets across the clusters of computers, which is called Hadoop Distributed File System, using simple programming models, which is called a MapReduce. So, when I say Hadoop is a framework written in Java, the entire architecture of Hadoop is written in Java. But of course, there is feasibility that not only you have to write your programming model in Java, but you can write in any other programming language, which we will look at another section. Okay. For now, let's get a solid understanding of Hadoop definition. Yeah. So we understood what HDFS is and what is MapReduce and how does they split the work and make the work to be done in a parallel manner. But when I'm looking at this particular definition, Hadoop software library is a framework that allows distributed processing of large datasets across clusters of computers using simple programming models. I came across a word called cluster. Right? So what is a cluster? And again, it is designed to scale up from single server to thousands of machines, each offering local computation and storage. Of course, like I said, when I take Hadoop distributed file system, I'll have plenty of resources, among which I'll have to distribute my work so that each work offers its own level of computation and each system offers its own level of storage. which will understand when we are looking at the cluster. So when we come across this particular technical jargon called cluster, let's look at what a cluster is. Yeah, this is my cluster. So let me say a basic definition of what cluster is. Cluster is combination of nodes. Combination of nodes is called a rack, and combination of racks is called a cluster. I'm repeating, combination of nodes is called a rack, and combination of racks is called a cluster. So what is a node? Here this host 11, host 21, host 31, 4151, or all these are nodes. So let's look at this in a way which we had seen in our example. In our example, we have 10 people to make our work done in a parallel manner. Same suits here. These are the resources which does your work in a parallel manner. A node is a resource or a slave which acts on the instruction given by its master. Okay, so here the host 11, host 21, host 31 are nodes or slaves which acts on the instructions given by its master. In our example, I am a master and all the 10 workers are the slaves. I made them to work in a parallel manner. So that can be imagined with this particular cluster. And the combination of nodes is called a rack. And combination of racks, as I said, is called a cluster. So each of this particular rack will have a switch, and all these racks will have a particular network switch as a whole. And why did we split a cluster into racks? There are many reasons. There are many reasons in terms of Hadoop. Let's take to Hadoop itself. We shouldn't deviate from Hadoop. When I'm saying about Hadoop, there are many reasons why we are opting for a cluster. Okay, I'll be using few technical jargons which we'll be looking in our next video. One thing will be rack awareness. Second thing would be your business continuity. Third thing would be replication. Of course, replication and rack awareness I will be dealing in my next video. But what is business continuity? Even if a node from when we have 3 racks here, one rack can be located at Asia Pacific, one rack can be located at North America, one rack can be located in South America. So if a rack goes down, there should be other racks available so that your business continues. That's what called as a business continuity plan, BCP. So for that purpose, we are splitting our nodes into racks and cluster. Okay, so this is how a cluster looks like. And just going back to the definition again, group of nodes is called a rack and group of racks is called a cluster. This is the basic definition of cluster, and this is pretty much important to understand, because later on when we are dealing with Hadoop architecture, we'll only deal with this sort of architecture, the cluster and racks. All the daemons of Hadoop depends on this particular cluster. So it's pretty important that we understand what a cluster is and what a rack is and what are the nodes. Okay, let's come back to the definition. Agenda. In this agenda, the takeaway are: what is big data? We understood big data as a collection of larger data sets which is difficult to be stored or analyzed in RDBMS. Second thing is definition of Hadoop. Hadoop is a framework written in Java to analyze larger data sets using a distributed file system called Hadoop distributed file system and a programming model called MapReduce. And we have seen what is HDFS and what is MR. And coming to cluster and racks, we have seen what a cluster is and what a rack is. So this is the end of the video. Thanks for attending my video.